Welcome to this explainer. Today we're taking a really fascinating look under the hood at the architecture of Kubernetes to understand exactly how it orchestrates your containerized applications. Look, if you've ever been totally overwhelmed by the sheer scale of modern software deployment, trust me, you are not alone. So let's just break this massive system down piece by piece until it all clicks into place. Here's our quick roadmap for today. We're going to meet Kubernetes, head inside the control plane, explore the worker nodes, weigh the trade-offs, and then finally answer the big question, should you actually use it? All right, let's jump right into section 1, meet Kubernetes. At its core, Kubernetes essentially exists to bring order to the absolute chaos of unmanaged containers. In the modern software world, applications are packaged into containers. But when you start dealing with hundreds or even thousands of them, managing that manually is virtually impossible. That's exactly where Kubernetes steps in. It's an open source container orchestration platform, and its whole entire purpose is to automate the deployment, the scaling, and the management of those containerized apps so your engineering team doesn't have to spend their weekends doing it. To really grasp its scale, we kind of have to look back at its origins. Way before 2014, Google was already managing the deployment of thousands of its own internal apps using this proprietary system they called Borg. And realizing just how revolutionary this was, in 2014, Google actually open-sourced a version of Borg, releasing it to the world as Kubernetes. Fast forward to today, and it's evolved into this massively popular, absolute industry-standard platform for container orchestration. Now, you've probably seen Kubernetes written out as K8s, which is just a fun little piece of developer trivia that instantly makes you sound like an insider. The number 8 literally just refers to the exactly 8 letters sitting between the first letter K and the last letter S in the word Kubernetes. It follows the exact same logic as other software abbreviations, like I-18N for internationalization or L10N for localization. Pretty clever, right? So, at the highest level, a Kubernetes cluster, which is really just a group of machines, is split into this fundamental dichotomy. On one side, you have the control plane, which is the brains of the operation, giving the orders and managing the state of the cluster, often spanning across multiple data center zones. And on the other side, you have the worker nodes. These are the ones doing the actual heavy lifting by running your containerized application workloads. Moving right along to section 2, inside the control plane. You can think of the control plane as the central nervous system of Kubernetes. It's made up of 4 absolutely critical components that we need to break down. Now, keep in mind, the control plane doesn't do the actual work of running your apps. Instead, it's constantly monitoring, dictating, and maintaining the desired state of your entire cluster. First up is the API server. Think of this as the front desk that handles literally every interaction between the control plane and the rest of the cluster. If an admin wants to make a change, or if a worker node just needs to report its status, it all has to go through this front desk. It exposes a RESTful API, acting as that primary interface so clients can submit requests and interact with the system safely. Next, that API server relies heavily on etcd. etcd is essentially the giant filing cabinet storing every single piece of crucial data about the cluster's state. It's a highly reliable, distributed key-value store. So this is where the cluster's persistent state lives. Anytime the API server or other components need to store or pull up vital info about configuration or current status, they're querying etcd. Then we have the scheduler, which is basically the intelligent dispatcher. Whenever a new workload needs to run, the scheduler looks at the resources that specific workload needs, checks the available resources across all your worker nodes, and then makes the critical placement decisions. It's all about ensuring maximum efficiency across the board. Finally, we have the controller manager. This component oversees all the background routines, acting kind of like a robotic supervisor with a clipboard. Its job is to make absolutely sure the actual state of the cluster perfectly matches your desired state. It runs various controllers, like a replication controller that makes sure your requested number of app replicas are running at all times, or a deployment controller for rolling updates and rollbacks. If a node goes down, this manager instantly notices the mismatch and gets straight to work fixing it. Okay, let's step out of the office and head down to the factory floor. Section 3, the worker nodes. If we zoom in from the massive cluster level all the way down to individual containers, we uncover this really fascinating nesting doll hierarchy. So a cluster contains multiple worker nodes. Inside those worker nodes, we have pods. And then inside those pods, we have the containers themselves. Understanding this specific structure is super essential to grasping how Kubernetes actually isolates and runs your software. Now, here's a super common misconception. Kubernetes doesn't actually run individual containers directly. No, it runs pods, and those serve as the basic building blocks for your apps. A pod is literally the smallest deployable unit in this entire system. It can host one or more containers, and what's really important here is that it provides shared storage and networking for those specific containers, basically bundling them together logically. Down on the worker node itself, we have the kubelet, which acts as the site foreman. It's constantly communicating with a control plane to ensure the right pods are running. The kubelet is just a daemon that lives on every single worker node. It listens carefully to instructions coming down from the API server and makes absolutely sure that the desired state of the pods on its specific node is maintained at all times. And working right alongside the kubelet is the container runtime, which handles the actual physical mechanical tasks. Once the kubelet gets the orders to run a pod, the container runtime steps up. It's responsible for reaching out to a registry, pulling down the necessary container images, physically starting and stopping those containers, and managing their local compute resources right there on the node. Now, to ensure all that network traffic doesn't just hit a brick wall, kubeproxy acts as the node's dedicated traffic cop. It maps out routes and provides load balancing by running on each worker node as a networking proxy. It just makes sure that when a user tries to access your app, their request is routed safely, evenly, and efficiently to the correct functioning pod. All right, let's talk reality check. Section 4, the trade-offs. There is a very, very clear balance here between incredible power and sobering operational cost. On the upside, Kubernetes is incredibly scalable and highly available. I mean, it gives you automatic rollbacks, self-healing, and rapid horizontal scaling to respond to user demand instantly. Plus, it's highly portable across different cloud or on-premise setups. But we have to look at the downsides. It is notoriously complex to set up and operate. The upfront cost is high because, frankly, you need specialized engineering expertise. It also requires significant resource overhead just to run the system itself, which can make it incredibly heavy for smaller teams. Which brings us perfectly to our final part. Section 5, should you use it? Unless you happen to have an army of highly specialized engineers and a massive budget lying around, the answer to whether mid-sized organizations should manage the control plane themselves might surprise you. Managing the control plane, that central nervous system we talked about earlier with the API server and etcd, is a massive undertaking that carries intense operational risk. Fortunately, there's a really great sweet spot compromise here, using managed services from cloud providers. Services like Amazon EKS, Google Cloud's GKE, or Azure's AKS handle all that deep expertise required to run the control plane, so you simply don't have to. By offloading this management, mid-sized orgs get the incredible scaling and self-healing benefits of Kubernetes without the sleepless nights of maintaining the underlying infrastructure. The cloud provider takes care of setting up the control plane, scaling the cluster, and giving you ongoing support. It's a real game changer. But if you are a very small organization looking at Kubernetes, our final takeaway is simple: YAGNI. That's an acronym for you aren't gonna need it. Because sometimes the absolute best architectural decision you can make is just knowing when a tool is plain overkill. Kubernetes is a marvel of modern software engineering for sure, but it is not a silver bullet for every small project. So as we wrap up this explainer, I want to leave you with one critical question to ask your team before you begin any migration. Are you adopting Kubernetes because your operational scale truly demands it, or are you just chasing the industry hype? Think carefully about that answer. Thanks so much for exploring this with me today, and keep learning.